CI/CD and how to make the process better in terms of deploying things to production when it comes to interactions with the database. So like what we believe generally is that whatever we do is we need to be a proactive and push to the left. Like you probably know the vibe. You implement some application, you use some ORM, some SQL, etc., etc. You deploy to production, and then you learn that things do not necessarily work well. They do not scale. They do not keep up with the load, with the different distribution and whatnot, right? So generally, this is what we disagree with. Like initially, what we want to have is we need to push all the possible checks, whether our application is going to work, we need to push them to the left as much as possible, meaning that we can't just deploy to prod, we can't wait for the load test to finish to figure out that, hey, the way we implemented SQL queries or whatnot is not going to work well with the database, right? We would like to push these things to the left as early as possible. And the other thing we want to do is we want to know the context, meaning that, hey, if something broke in the production system, we want to know that what exactly happened. Not only that this query was slow or this query didn't work, but we also want to know, hey, what's the stack trace? What's the root cause exactly? What was the REST API code? What was the endpoint that was hit? We want to get full observability, full context, everything around that to troubleshoot and root cause the issue as early as possible, right? And we believe this is a must-have for every single application. This is like a completely different approach we propose because we just can't wait for these things to pop up in production. We need to identify them as early as possible, right? So you might actually ask, hey, can I deploy to production on Friday? And I tell you, obviously you can. You sure you have unit tests, etc., etc. You deploy to production, you have your CI/CD, and it works well, right? But does it? The thing with CI/CD is that if you want to check your code against a large scale, you need to actually run load tests. Load tests happen very late. They're expensive. They take tons of resources, something that is not necessarily easy to be done. And when we do load tests only after we are done coding, that's already kind of too late to figure out what can be wrong. However, they tell us we get CI/CD solves all the issue, right? Just to set the definition straight, continuous integration, you build the code, you compile your application, you run your unit test, end-to-end integration test or whatnot, and you then make sure that this application works to some extent, right? Then continuous delivery and continuous deployment, you build the package, you deploy it to either non-production environment or to production environment, like automatically. However, like believing that this package will work well in production, right? And sometime along the way, we have the load tests. They typically happen just before we release a software to production, right? And this is kind of way too late because what can go wrong? There are multiple areas that can go wrong when we are talking about successful software development, right? So we have, for instance, bugs in like our application code. When we have problems with the deployment. You deploy something for Windows or for Linux, you forget to copy IAM role permissions to AWS console, you forget to adjust connection strings, environment variables, and whatnot. So even though you tested your application locally, that does not necessarily mean it's going to work well in production, right? The other thing that may break is your code doesn't work well in production because you have some bugs, you have different data distribution, you have different edge cases, different traffic, peak hours, off-peak hours, super off-peak hours here in the UK. Generally, things may go completely differently, right? And this is something that cannot just, you can't test that reliably locally, right? But the most important part is your database or the code interacting with the database may not scale well. Why? Because you have different data distribution, because you use different license for your SQL server, right? Because you use actually completely different SQL engine. If you test things locally using H2 in-memory database, and then you deploy to some PostgreSQL instance or Oracle instance, this is a completely different database. Even if you go with RDS in AWS, right? This is technically a different implementation of a database, so things may break. What we want to propose is a completely novel approach that you actually verify that everything works well without doing or before doing those load tests and before going to production by doing the stuff properly and injecting all your statistics as early in your development process as possible. So we'll get to that in a sec, right? Let's see what problems we may get when we are talking about databases. There are generally three big groups of problems that we see. First group is generally you change your application code, This resulted in different SQL queries being executed. Different SQL queries work differently. They use different indexes and whatnot, and they generally fail, right? The other thing that may not work well is schema migration. So you have different schema, you added column, you removed column, you broke something along the way, or you changed the performance overall, right? But the third thingy, which is also crucial, is that your query executes differently in production versus in non-production environment. Why? Because you have more data in production, because you have different indexes configured, because you have different index users, because you have different statistics, whether they are refreshed or not. You have different log contention, you have different like traffic going on and whatnot. All those things, they actually affect how you do the stuff, and you learn about these things only when you deploy to production. And we want to change that. Let's go through a couple of like things that may actually break when we are talking about the databases. So let's say that we have like this aggregate root here. So what we would like to do is like we want to get this user for ID 123. This is an actual production case that we observed in one of our systems, right? So you do left join, you load a lot of details for this aggregate root, like your locations, questions, etc., etc. This results in this big SQL statement, right? And this big SQL statement loads 300,000 rows for your ORM just to build one single aggregate root, okay? This runs for 25 seconds. Would you spot that in your dev environment? You probably do not even have rows to generate 300,000 rows going to your ORM, right? This is something you won't get just by looking at your application code. Not at all, right? But this is something that once you deploy to production and once you load your run your load test, you immediately see it's not going to work well. How can we fix that? Like now, depending on the problem we have, there are various ideas how we can fix the problem. For instance, in our case, the solution was just to split this aggregate load routing into various like subcomponents that we execute like separately, and we end up with 8 different SQL statements. Like that seems like not a good idea. Why 8 statements versus 1? But all those are super small, and they can finish in like 1 millisecond, and we get then an application code that doesn't need to deal with 300,000 rows in the ORM. That works way better, right? So this is something we could do, but there are other problems we may see. For instance, if you wanted to be like, let's say, write a clean code, clever code, etc., use CityJS. So we have a table that is like what, 8 million rows in here, as you can see, and we are just getting some data. We want to get the boarding passes and calculate like the double hash of the ticket number, right? If we use CTE and then join these things like accordingly, this runs in 13 seconds, okay? If you do it the naive way without taking care of like your code being clean and whatnot, this runs in 8 seconds, right? This is obviously a handcrafted example just to show you what's going on. But imagine that you do not have 8 million rows in your dev database, right? But it's something like 100 rows. Is it going to work well? Probably not at all. So this is why we need to have some better approach for observing the performance without actually waiting for the load test and production environment, right? Another thing that may work differently is missing indexes. So you work with your database, you work with your tables, it's slow. What do? Just add an index. What happens if you tell that to your junior developer or newcomer in your team? You end up with this, index all the things, right? So you have too many of those indexes, right? So just blindly adding indexes here and there is not a solution either, right? You need to understand what's going on. You need to have observability of your production system. See whether those indexes are used or not. See how it actually performs in the real life system without like just blindly adding things here and there, right? Those are problems with databases. Another problem we may have, obviously, is you have bugs. Like you made a bug in your code, you forgot where, or you implemented your code incorrectly, but it is something you won't figure out like easily because it hits some data distribution or different peak hours and whatnot. You also have problems with actual SQL engines or databases that you use. MongoDB loses data. SQL database may actually skip rows if you run with default isolation level like read committed, right? You may have problems like Halloween that actually makes your database calculate things incorrectly. You need to figure that out before going to production. Otherwise, you risk losing and breaking your data overall. On top of that, we also have problems with ORMs itself. Meaning that if you use the ORM library, the worst part of ORM is that it hides so much of the configuration behind the scenes, right? The one problem you probably all know about is like n+1 selects. So we have aircraft stable that is related in like one-to-many with seats. And we write up like seemingly innocent code that basically loads all the aircrafts, and then for each aircraft we just get the seats, right? What could go wrong? And in this particular example, what we have is we first select all the aircrafts. That's one select statement that is sent to the database, and then we send every select, like for every single object in the aircraft table that we extracted to get additional things. And this is n+1 problem because we ultimately get one query for aircrafts and n additional queries for each of them. Right? How can we fix that? Well, we can reconfigure our ORM library to basically send work in eager mode to load all the data automatically for us, right? But if we reconfigure our ORM library, then first, we do not see the configuration in the application code itself. It's hidden from us. It's somewhere else, right? But the other problem we have is we end up with the same query as before. Like we already saw that, like join too many tables. So it's not like a silver bullet. Change this configuration, it's going to work. Add this index, it's going to work. Nope. What we need to do is we actually need to get this parity of getting things locally and comparing them with the production server as early as possible to figure out whether it's going to work well or not. Other issues include things like, let's say, polymorphism, impedance mismatch. So how to represent inheritance in SQL databases, right? How to represent various data types, for instance, strings with like case-insensitive characters or whatnot. How can we represent all of that, especially when we change our database implementation? We were going with Postgres, now we go with Oracle, with RDS, with whatever, and those things break, right? How can we figure out all of that? Ultimately, ORMs, what they do is they add on top of our like problems, existing problems with databases, they add another things that are like hidden moving parts, triggers, stored procedures like migration, schema management, and whatnot. Those things are scattered around our code base, are scattered in like application code, in configuration code, and whatnot. They are hidden behind the scenes in various places, and it's generally very hard to reason about that. So what we would like to do is, we already see the problem. We do not get a true performance impact without doing load tests, and we don't see all the things that happen before like we go to production, right? How can we make it better? That's the question we would like to answer. So what we are going to do is, we would like to know the context. We would like to provide a full observability, transparency, and monitoring to everything we do, so we can reason about our code and can reason about everything we have before we go to production. How to do that? Well, very first thing we need to do is we would like to understand how SQL interaction works behind the scenes, and then we would like to get enough metadata and context for us to actually make meaningful assumptions and meaningful outcomes when it comes to the optimizing the performance or what. When it comes to SQL engine, the typical way your query is executed, no matter what query it is, select statement, simple ones like also complex one, it goes through various phases. First, it is parsed by your SQL engine to some standardized form, and then it's rewritten to make it unified, standardized, etc., so the SQL engine can reason about the query like in a great way. Reason in order to prepare the third part, which is plan, meaning that SQL engine, before going and grabbing all the data from the database, it would want to plan how it will do that thing, whether it is going to use this join strategy, this index, that index, is it going to filter first or filter later and whatnot. And finally, the SQL query is executed based on the plan we provided. What is the plan? Let's see it in action. So if you, for instance, take Postgres, you can add this explain keyword at the very top to your SQL query, and this thingy is going to basically show you the query plan that we see on the right? And this query plan explains everything, what's going on, what's going to happen with the query. If we now dissect this plan a little bit, then we can, we can figure out that each row is a node that explains some kind of operation. And each operation may be of like different types. For instance, it can be a table scan, sequential scan, or this could be an index scan to get the data. This could be some filtering, joining, and whatnot. But ultimately, what is important for us is the cost. Every node in this plan has a cost associated with it, so that SQL engine can generate multiple plans together and compare them and choose the cheapest one. That's the ultimate idea. SQL engine creates multiple plans, chooses the cheapest one to do the query as fast as possible, right? And the cost is basically an arbitrary number telling you how this thing is going to to be executed, how hard it is to execute it, mostly in terms of like I/O operations, reading data from the hard drive, not using caches because they are not available, refreshing buffers and whatnot, right? So this is what we can get from the SQL engine to actually tell about the performance of our like query, how it's going to work. What else can we do? Let's say that we were able to get those details from the SQL engine, right? No, now what we would like to do is we would like to provide a full transparency and monitoring to actually correlate these things with our application, business code. So what we would like to do is we would like to use OpenTelemetry. This is like a well-known, well-funded standard nowadays that allows you to like capture logs, traces, metrics, and whatnot, and tell you exactly what's going on in your application, right? So it tells you, hey, this thingy was called, this is how long it took, etc., etc. The way it works is it is based on various signals. Like OpenTelemetry is a set of standardized SDKs that you can drop into your application, whatever language you use, whether it's JavaScript, Python, Java, .NET, whatever. You have an SDK that works on the same standard and gives you those signals that are like traces, metrics, and logs. And how you can use them is you build a thing that is called trace and span. So let's take an example here. So what we have is we would like to basically reason about our query that, let's say user wants to do a checkout or trigger some business operation, right? Buy something, right? So the request comes to our server A. This is like a load balancer, web server, or whatnot. And then server A must call something like, I don't know, payment service, database, or queue behind the scenes. Then payment service calls some other things, etc., etc. OpenTelemetry allows us to capture like JSON objects, just like we see here on the left, and build things that this is like a trace showing whole operation. What's going on? So you can see that, hey, this operation A took this long, this amount of time, then it called B, C, D, E behind the scenes. This is what you can get using OpenTelemetry. So you finally get some insights into what's going on behind the scenes, how it works behind the scenes, right? So this is what we get with the OpenTelemetry. We know about like SQL query plans. Now the only thing we need to do is we need to connect all of that together and finally build something that will help us to build those database guardrails as early as in our pipeline as possible. So what we would like to do is we would like to be proactive and push all those checks to the left as early as possible, right? We want our application to be performant, we want them to work well, and we need to figure out whether they are going to work well in production without actually doing load tests and without going to production, because it's too late, too slow, and very expensive. And also finding bugs in production is something that we can't afford because, well, it's kind of too late and also users are affected, right? So what can we do? And what we do is we can use Metis to help that situation. So Metis is a platform that uses OpenTelemetry and uses those SQL queries, statistics, and whatnot to provide you a full observability and full monitoring of everything behind the scenes. So Metis will cover your source code, your pull requests, your database observability, and whatnot. So let's see how it goes behind the scenes. So when you create a project in Metis, what you have is three important components here. You have staging showing you like non-production environments, pull requests for CI/CD and production environments. So let's go to staging. When you integrate Metis with your app, which is like drop in one NPM package, one line of code for integration, you get to something like this. So you get like an actual information that, hey, your application did this call to put like V1 analyst checking API. When you open that, you get like immediately full monitoring on observability of what's going on. You can see that, hey, this was the REST call. Those are the SQL statements that were executed. This one, for instance, read 7 million rows. This is rows read. This is like table scan. Those are the databases there. Those are tables that were used and whatnot. So this is what you get immediately just with like one line of code. You can obviously go to some like more detailed information. For instance, this was the SQL query that was executed. Those are the metrics of your database. This is like the query tail of everything that happened behind the scenes. This is what your SQL engine did. Execution plan and whatnot. But more importantly, this thing is telling you, hey, this is critical issue. This won't work well in production. This uses table scan. This is the impact, and this is how you can remediate this situation. Just add this, just add that. It provides you stack traces, context monitoring, and everything like this, okay? If you wanted to integrate that with your CI/CD, nothing easier. Like you go to, you create a pull request. In order to integrate Metis with your pull request, you just drop in one new action to your GitHub action, right? You configure pull request, and then you get Metis automatically commenting on your pull request that, hey, those are the things that didn't work well. And you can see all the insights analysis for you automatically just based on what you did. And the important part is, this takes statistics from your production database and injects them into your local queries that you executed to tell you, hey, this query worked well in staging environment, but will fail definitely for sure in production, right? The other thing we provide is we build this observability for monitoring databases. So if we go back to the main page of the project, you can see that we have production hosts here. You just drop in one Docker container that runs every couple of hours, get some statistics, and you get, for instance, this behavior that you say, hey, those are the tables you have in your database. This is the table size. This is the number of rows, etc., etc. You can go more to details like this is the index usage you have. Those are the indexes. Those indexes, they do not work well. They are not used quite recently, etc., etc. You can also go to other things. For instance, query statistics. So this is what is showing you, hey, your production database actually was running this queries recently. If you choose this query, you can see this is the performance of this query over time. How it executed, right? You drop that in, integrate that with all your applications, all your databases you have, and this generally provides you this full observability, and more importantly, you get it at your hands when you are implementing your application code. Not during load tests, not during stuff like you do in very late, but generally super early. So to summarize what we have a source code integration using open standards, open telemetry, and whatnot, which supports multiple languages, multiple platforms, drop in one line, and that's good. We do have covered your CI/CD pipeline now so that you can improve this whole performance. And finally, we do have full observability, like a web page, like a pull request, like CLI tool, CLI tool, if you want to do some custom hand monitoring and whatnot. This is all you get, with Metis out of the box, just by dropping in one package, one line of code integration. Summarize. Things may break along the way in multiple ways. Databases may go wrong, ORMs may go wrong, and whatnot, right? We can't wait for load tests to figure out this performance. We need to push these checks to the early as possible. We need to have database guardrails from the very first step when we do our application coding, right? And Metis gives us all of that. It covers all our parts of all our databases, provides us root causing, context, observability, and whatnot. If you had any questions, we have a stand right behind this wall. Feel free to come, approach us, ask us any questions you have, and we'll be happy to answer. And being all of that said, I'd like to thank you for coming to this slot. Hope you liked it, hope you enjoyed it, and have a great rest of your day.
That was an amazing 1.5x talk, speed-wise. So it's good. It's just speeding up my YouTube at home. It was cool. Good job. So yeah, if you have questions, feel free to ask him. Lauren, if you want to come up and set up, that's cool. I think it's Lauren. I wasn't feeling very funny this morning, so I decided to ask ChatGPT for some jokes to tell. So I asked it for some jokes about JavaScript and the matrix. So I'll share a few now and a few later because they're really awesome. So how does JavaScript developer escape the matrix? Any guesses? You can come set up your laptop while I'm telling these terrible jokes.